Hi, let's talk about finite decimals and their expanded form. So let's look at what we have here. I have the whole number 68,593, and you may recall that we may write it in expanded form in this manner, or if you are comfortable with powers of 10, we may also write it in this manner, the expanded form. So we ask, can the finite decimal 68.593 also, can it be written in a similar manner in an expanded form? And today we'll try to answer that. So let's look at 68.593 and work our way through and see if we can write it in a completed expanded form. So by definition, this finite decimal is in fact a decimal fraction, and I'm assuming you're now comfortable with powers of 10, writing powers of 10 in this manner, using 3 as an exponent. So here this finite decimal is in fact this fraction with this 10 cubed in the denominator. And now what we do is we look at 68,593, we just reviewed it, and we may write out its expanded form in this manner. And then since we know how to add fractions, this expression can in fact be written this way. It may be easiest for you to look at this and say this is simply adding fractions with the same denominator, 10 cubed, and then that means this expression, which is the sum of many fractions, is simply this fraction with the common 10 cubed as the denominator, and numerators, as you can see, are this guy plus this guy plus this guy. That's what it's put together. I just pulled apart the sum into its different components. So, and then now we look at each part together. 6 times 10 to the 4 over 10 cubed. The 10 to the 4 is 10 cubed times 10. The 10 cubes by cancellation law cancel out, and what you get is really a 60. With similar reasoning, convince yourself that this is simply 8, and here 10 cubed is 10 squared times 10. By cancellation law, we can cancel the 10 squared common factor, and we would get 5 over 10. And here with similar reasoning, 9 over 100, and with similar reasoning, 3 over 1000. Remember, 10 to the 0 is really 1 by definition. So what have we arrived at? We are saying 68.593 is exactly same as 60 plus 8 plus 5/10 plus 900 plus 3000. That is the completed expanded form of this. And if you wish, you can rewrite this where instead of 5 over 10, we write it as a finite decimal 0.5, and we write this as the finite decimal 0.09, and we write this as 0.003. So let's do that out here. So this is what we get for the expanded form of 68.593. 60 plus 8 plus 0.5 plus 0.09 plus 0.003. So that means this 6 here stands for 60, 8 stands for 8, and this 5, this first decimal digit 5 stands for 5/10. The second decimal digit 9 is really 900ths or 0.09. This third decimal digit 3 is really 3000ths or 0.003. So so even though I've used this example and have gone over the details of how to write a finite decimal in its completed expanded form, you can use the same reasoning on any other finite decimal. Thank you.